Good morning, class. Calculus 1, Chapter 2 review, limits and derivatives. Here's exam 1 covering from 2.1 to 2.8. Here's the third part covering 2.7 and 2.8, 2.7 derivatives and rates of change, 2.8 the derivative as a function. We want to look at that. So given the function y equals f of x and a point with coordinates a and f of a, the slope of a secant line PQ is average rate of change. Everybody remembers when 2 points are given, how we find the slope? The slope is rise over run, delta y over delta x, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So you have 2 points. You calculate this. Now, if you stick with what we have here, take a look. If we go with this one, okay, just the way it is, you're going to say f of x minus f of a over x minus a. So if I write it in this format, that's the same as this one. If we keep this as a and we call this distance h, which is the run, and this distance, of course, is the rise. So this becomes a plus h. A and f of a doesn't change, but this one is a plus h. This is f of a plus h. And according to this formula, f of a plus h minus f of a is the numerator. And then a plus h minus a, which makes it h, is the denominator. If we call this point b, okay, and therefore this point has coordinates b, f of b, the formula becomes f of b minus f of a over b minus a. My point being, all of this refer to the same thing, slope of the blue line, which is known as a secant line, rise over run. These two pieces normally, especially this one, is known as dq, the difference quotient. Now, as we get closer and closer to the p, so q gets closer and closer to the p, these secant lines get closer and closer to what we call a tangent line. So the tangent line is the limiting position of a secant line PQ as Q approaches P. Slope of a tangent line, also known as instantaneous rate of change, would be the limit of M of PQ as Q approaches P. So the slope of this PQ as Q approaches P, or the limit, if you go with this one, the limit of f of x minus f of a over x minus a as x approaches a, as x approaches a. If we go with this one, the same thing, the limit as h approaches 0 when h becomes 0. Now, of course, this one is the slope of a tangent line, also known as the instantaneous rate of change, also known as the derivative f prime at x equals a. Now, we are interested in finding the equation of a tangent line at the point a comma f of a. Well, here's the standard form, different types of lines, ax plus by equals c. Point slope y minus y1 equals m times x minus x of 1. And here's the slope intercept form, y equals mx plus b. If you stick with the point slope and using this pair, you would say y minus f of a equals m times x minus a. Now, what is m f prime of a? So I want you to pay attention to the equation of a tangent line. Do I have to memorize it in this format? No, just stick with the point slope from elementary algebra and it works just as fine. Okay? I hope everybody's comfortable with that. All right, let's look at this very simple example. We want to find the derivative, also known as instantaneous rate of change of f of x of the function f of x equals x squared minus 8x plus 9 at x equals 5. Well, we can use one of these two, and later on I'll try to use both of them for practice. I'm going to stick with this one where a is a 5. So I want the limit of f of 5 plus h minus f of a over h as h approaches 0. So let me write that at top here. I'm looking for the limit as h approaches 0. This is f prime of 5. F of a plus h, 5 plus h, minus f of a, f of 5 over h. So what does it mean? Into this function, plug in 5 plus h, so we write the same thing, the limit as h approaches 0 of 5 plus h squared minus 8 times 5 plus h plus 9, and then we plug in 5 minus 5 squared minus 8 times 5 plus 9. So just plug. I hope you realize this is elementary algebra. You have to simplify this. In some cases, people just do this, simplify it. At the end, they apply the limit. In some cases, we keep the limit. Of course, everybody remembers this is 5 squared is 25 plus 2 times 5 times h plus h squared. And so we have 25 plus 10h plus h squared. We have minus 40 minus 8h plus 9. We have minus, this is, well, we can simplify and then distribute, or we can change this to 25, this one to 40, and distribute the negative. And the reason I do that, it makes it easier to see that 25 and negative 25 cancel each other. Minus 40 plus 40 cancel each other. Positive 9, negative 9 cancel each other. I think it makes it easier to see. Also, now we have 2h plus h squared. We factor out the h from the numerator. We drop the common factor of h. If we plug in, we get 2. Please understand, we are applying the definition, okay? Find the derivative of the following functions. Again, some of you have had some calculus before, and you know how fast you can get that using the formulas, but we are going to use definitions. I can't emphasize this enough. We are going to use definitions, everybody. So we are going to find f prime of x using this formula. So it's the limit as h approaches 0 of f of x plus h minus f of x. So 5 times x plus h plus 1. We are using this formula. Then minus f of x is 5x plus 1. So plug in to this formula and evaluate. So again, what is f of x plus h? 5 times x plus h plus 1. And what is f of x? You just write it. And all you have to do, distribute, you get 5x plus 5h plus 1 minus 5x minus 1. And clearly, 5x and minus 5x cancel each other. 1 and negative 1 cancel each other. And the numerator is left with 5h. And h drops. The final answer is 5. We are going to use this formula for part B. So f prime of x is the limit as h approaches 0. The numerator f of x plus h, 2 over x plus h, minus f of x, the same thing, 2 over x over h. Okay. Again, plugging in and evaluating is elementary algebra. This is a complex fraction, right? And if you plug in, you get 0 over 0. The technique is LCD, which is x times x plus h. You're going to multiply and divide by it. It's important to know that the denominator, you just keep it as a product. The reason, again, h is approaching 0. The denominator of 0 is a problem. We are hoping to get rid of that. When you multiply this by the first one, you get 2 times x. By the second one, you get negative 2 times x plus h. So again, all of it is algebra. Notice this is algebra, this is algebra. Now you distribute, you get minus 2x minus 2h. 2x and minus 2x cancel each other. H and h cancel each other. And now if you plug in, you get minus 2 over x squared. So again, some people, they find this, and then at the last step, they put the limit and apply. It is important to know you must have a lim sign in order for h go to 0, otherwise it's not the case. Find an equation of a tangent line to the graph of the function f of x equals square root of 3x plus 1 at x equals 8. In order to find equation of any line, you need two things. You need a pair and you need the slope. The pair you just plug in. Which means 8 times 3, 24 plus 1 is 25, square root is 5. So the pair is 8 comma 5. So plug in the pair x comma y becomes x comma 5. To find the slope, we use either f prime of x and then we put in 8, or we find f prime of a, namely 8 in one shot. It's up to you. So I'm going to go with f prime of x, and I'm going to use this formula. So f prime of x is the limit as h approaches 0, f of x plus h. So the square root of 3 times x plus h plus 1 minus f of x is this function over h. So this is f prime of x by definition. And so I hope you realize if you plug in, you get 0 over 0. The technique is the conjugate of the numerator. So we're going to multiply and divide by it. And this expression is 1. That's why we learned the limits, and especially the types of limits that, as you recall, it was called indeterminate. We mostly deal with indeterminate forms in calculus. So when we multiply, what happens? First and foremost, we don't ever touch the denominator. We keep it as a product because, again, h is approaching 0. It creates a 0 in the denominator, and that's the problem, not the 0 in the numerator. So with that being the case, we keep this as a product. When we multiply these two, you're looking at a minus b times a plus b. The result is a squared minus b squared. Which means each radical comes out. Again, that's elementary algebra. We should have no problem with that. We're going to distribute. We get 3x plus 3h plus 1 minus 3x minus 1. And so what happens, you notice 3x and minus 3x cancel each other. 1 and negative 1 cancel each other. The numerator is left with 3h. And that's a good thing because h and h, they cancel each other. And here's the limit. Now, what happens if I plug in 0? This becomes identical to this. And so f prime is 3 over 2 square root of 3x plus 1. We already have the pair. How do we find the slope? Plug in 8 into f prime of x. So m is f prime of 8. So if I plug in 8, we know this becomes 5. So 3 over 2 times 5, or 3 over 10. We showed that this ends up being 5, right, everybody? So this is being 5. When you plug in 8, this is 5. 2 times that is 10, 3 over 10. So y minus y1 equals m times x minus x of 1. Therefore, y minus 5 is 3 over 10 times x minus 8. If you distribute, you get 3 over 10 times x minus 3 over 3 times 8, 24 over 10. 24 over 10, that's the same as minus 12 over 5. And if I add 5 to both sides, 5 is the same as 25 over 5. And we get y equals 3/10 of x plus 13 over 5. Okay, now what I want to add here, if you plug in the pair and works, it means this process is right. Doesn't say anything about the slope, whether that was correct or not. But it's very straightforward. So a quick recap. How do you find the equation of any tangent line? Or any line? First you need a pair, then you need the slope. The pair you just plug in. Sometimes they give you the pair, sometimes they just give you the x coordinate. How do you find the slope of a tangent line? You differentiate the function and you plug it. The graph of a function f is given in the figure. Use it to sketch the graph of the derivative f prime. Okay. Let's explain a couple of things here. Relative extrema, max and minimum, occurs when f prime is 0, the peaks and valleys. Local mean, local max. F prime is positive, f is increasing, f prime is negative, f is decreasing. So the one that looks like a positive, a line with a positive slope. So clearly decreasing, increasing, decreasing, increasing. So if we look at this concept, these points A, B, C, they correspond to m being slow, the slope being 0. I'm going to discuss that at the end. You can ignore it for now. So this corresponds to 0, this corresponds to 0, this corresponds to 0. So if we were to graph this quickly, so this corresponds to 0. For the graph of its derivative. Obviously, it's decreasing here. and here it's increasing here, as I mentioned. So when f prime is when the function is decreasing, that means f prime is negative, that means below the x-axis. So this part, so somewhere below, okay? And then becomes increasing, so it has to come back up because f prime is positive, but it has to go back to 0. Let me, then again is decreasing, so it has to go below the x-axis and it has to come back to 0 again. Over here, f prime is negative, comes back to 0. F prime is positive, it's increasing, so it goes up somehow. This is not a perfect answer, but it's close enough. Now, what happens to this point? Let me erase the mess. What happens to this point? They picked a point and they did their best to draw a tangent line. They picked up 2 pairs and they calculated this slope as 3/2. Now, this will correspond on the graph of f prime of x for the point 5, comma, the y coordinate is 3/2 or 1.5. So let me again erase the mess. It will look like this. Okay, everybody? It will look like this. The graph of a function is given, use it to sketch the graph of the derivative f prime. We start with the easiest possible answer. Any line, all you have to do, calculate the slope. So if the slope is, let's say, m equals 10, then y equals 10 is the answer. So any line, you calculate the slope. Y equals the slope is the answer. So how do we calculate the slope? Pick up 2 pairs, for example. This point has coordinates 0, 0, clearly. This point has coordinates 1 and 3 because this is 6. The scale along the x and y axis, they don't have to be the same. So this is number 6. So this one is 3. And clearly the slope becomes 3. So the line y equals 3 is the answer. Y equals 3. M equals 3. So y equals 3, which is a horizontal line. So to recap, if you're given a line, calculate its slope. How? Pick up 2 pairs. Rise over run, y sub 2 minus y sub 1 over x sub 2 minus x sub. And then the line y equals the value of the slope, which is a horizontal line, is the answer. What about this one? There are points that we have as peaks and valleys. Normally, this means you have a local max or local mean, and they correspond to 0 on the graph of f prime. That means on the x-axis. So this one corresponds to this point. This one corresponds to this point. This portion is increasing, everybody. Let me. This portion is increasing, and therefore it has to be above the x-axis. Let me actually do this. It may be easier if I show you on the same function. So if I go with this point and this one with this point, and I say this portion is increasing, which means above the x-axis, something like that. This portion is decreasing, right? So means below the x-axis, but I want to make sure everybody understands what's happening. This is entirely below the x-axis, but this corresponds to 0, and this corresponds to 0. So although it's below the x-axis, it has to come back up at some point. We may not know exactly when, but it has to come back up. Let me use a different color on that. So it goes below the x-axis, but it has to come back up. This portion is increasing, which means f prime is positive. So it has to come back up. So that's why we get the graph as follows. Let's look at this function, and this corresponds to a local max or mean, and the f prime represents at that point 0, which happened to become 0 over 0. And so this part, let me use a different color. This part, okay, is increasing, which means f prime is positive. So it's above the x-axis, and doesn't have to look good. It's roughly that, and this portion is decreasing, which means f prime is negative, so it has to come back down somehow. Okay. Pretty straightforward, I believe. That's how you do the graphing. How can a function fail to be differentiable? 3 ways. If we have a corner or simply a sharp corner, if we have a discontinuity, if we have a vertical tangent line, a corner or kink, the graph of f has no tangent line at this point. The left and right limits are different because you want to draw a tangent line. How do you do that? If f is not continuous at a, then f is not differentiable at a. So at any discontinuity, for instance, a jump discontinuity, f fails to be differentiable. A vertical tangent line, the limit of the absolute value of f prime of x as x approaches a is infinity. The graph of a function f of x has a vertical tangent at the point a comma f of a, if and only if the limit of f prime of x as x approaches a is negative infinity, or the limit of f prime of x as x approaches a is infinity. Both sides have the same result. So the limit of the derivative, okay, in other words, in essence, the second derivative of the original function, it blows up to infinity or negative infinity. Now, this is called cusps. The limit of f prime of x as x approaches, for example, in this case, 0. From the right is infinity, from the left is negative infinity. And so what it means is the following. When the graph of the function becomes vertical and then virtually doubles back on itself, Such pattern signals presence of what is known as the vertical cusp. In general, we say the graph of f of x has a vertical cusp at a and f of a, if and only if the limit of f prime of x as x approaches a from the right is infinity, from the left is negative infinity. It doesn't have to be infinity. It could be negative infinity here, positive infinity here. They are, or vice versa. Both sides do not have the same result. In other words, when you look at a vertical tangent line, both sides have the same result, positive or negative infinity. In this case, they have different results. That's the idea. Okay. Now, to make some sense out of this, let's look at this example. The graph of a function f is given where and why the function is not differentiable. Clearly, at x equals 0, because there's a discontinuity. Clearly, at x equals 3, it's a vertical tangent line. If you think this is a sharp corner, I have no problem with that, but I'm going to show you how you distinguish between the two in a moment. Clearly, at x equals -1, we have a discontinuity. Clearly, at x equals 2, we have a sharp corner. So how do we distinguish between a sharp corner and a vertical tangent line? If you look at a sharp corner, class, it looks like a V shape, or maybe upside down V shape. Whereas this one, it seems to going up. This is not a V shape. This is V shape or upside down V shape. If you confuse the two, it's really not that big of a deal. The graph of a function f is given. Use it to sketch the graph of the derivative f prime. So we should notice that we have 1, 2, 3, 4 line segments. We also should notice that there is a clearly sharp corner. You see the V shape. Sharp corner here, 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 which means at these 3 points, it fails to have a derivative. Sharp corner, clear. So let's assume, I want to make sure that we understand what's going on. Let's assume we had just this line. Never mind the rest. I'm going to call it L1. If we had L1, all we had to do, calculate the slope. And if the slope, okay, so M, we would have to calculate the slope. And then the equation of a line y equals M would be our answer, and we are done. And that's fine. So understand you have 1, 2, 3, 4 of them. So first, assume they are lines, and for each line, calculate the slope. And then be more careful by looking at where the line ends up, and it becomes a line segment, a portion of a line, rather than a complete line, okay? So let's clean up. This one, this one, this one, and this one. So let's plug in some pairs, and they may not be to scale. They're most of the time given to you, so or it's very easy to read from the graph. So for example, over here, if I want to calculate the slope, I use rise over run. And so 0 minus 1 over -1 minus -3, and the slope becomes 1/2 for this line segment. And I hope you recognize for this one, if this is -1/2, this is +1/2. -1, 0, 0, 1. I hope you see you can calculate this as +1 and this one as -1. So you calculate all the slopes. So for this one, we would draw y equals -1/2. For this one, y equals 1. For this one, y equals -1. For this one, y equals 1/2. So y equals negative 1/2 is this line, but it stops at this point, right? And why is there a hole here? This is a sharp corner, everybody. This is a sharp corner. This is a sharp corner. For this one, we draw the line y equals 1, and we stop from here to here. So y equals 1 from here to here. Y equals 1/2 from here. It may be continuing indefinitely, we don't know. And over here, just from 0 to 1, we have m equals -1. I hope it's clear to everybody. So I believe it's pretty straightforward. That's how we find the graph of f prime, roughly. Here's the function, and we want to find the limit as x approaches -infinity of square root of 1 plus 4x to the power of 6 over 2 minus x cubed. When we are dealing with roots, how do we deal with them? Remember, if it were a rational function, because x approaches negative or positive infinity makes no difference, we would divide by highest degree term in the denominator. So how do we do that for the numerator? First and foremost, inside the radical, I can take the common factor of x to the power of 6 in the following manner. This becomes 1 over x to the power of 6, this becomes 4, and x to the power of 6 comes out. Now, it's important to know when it comes out, what happens to it. Okay, does it come out as x cubed, minus x cubed, which one, why? Let's pay attention to that. In case of a limit as x approaches infinity, in other words, when we say x approaching infinity for x larger than 0, if you recall, the square root of x squared is absolute value of x. When x approaches infinity, then it becomes x. You don't need an absolute value. And if it's negative infinity, the absolute value becomes minus x. That's extremely important to know. Therefore, when we are looking at the square root of x to the power of 6, if x was approaching positive infinity, we would go with x cubed. Because it's approaching negative infinity when x is less than 0, this means x is less than 0, then it changes to minus square root of x to the power of 6. And therefore, when it comes out, it creates a negative sign. And now, because x is approaching negative infinity, we divide by highest degree term in the denominator as follows. So what happens is, this just drops. You get the square root with a negative in front of it. This becomes 2 over x cubed. This becomes -1. And because x is approaching, doesn't matter infinity or negative infinity, this piece this will go to 0. This will go to 0. And we get this. Now square root of 4 is 2. Minus in front of it makes it -2 over -1, positive 2. So to recap, what happens to this piece when you want to take x to the power of 6 out? If it's x to the power of positive infinity, is x cubed. If x is approaching infinity, is x cubed. If it's x approaching negative infinity, then it's minus x cubed, according to the definition of an absolute value. Again, this is regarding square root. It's a cube root, you don't have to worry about that. Positive comes out, negative comes out. Find the limit of x squared over square root of x to the power of 4 plus 1 as x approaches infinity, and reminding you of what we said in the previous case. Notice x to the power of 4. I mean, if it comes out, it's either x squared or minus x squared. We're going to figure out which one. But before we take it out, we can take the x to the power of 4 out as a factor inside the radical sign. When it's inside the radical sign, you don't change anything. Now, because x is approaching a positive infinity, this comes out as x squared. See, x squared is square root of x to the power of 4 when x is positive. So it comes out as x squared. So this inside is the same as this one outside. So now we can drop the x squared from the top and the bottom, and the numerator is 1. If you plug in infinity, this goes to 0, and square root of 1 is 1, and the final answer is 1. And I hope you see how we are approaching this concept. All right, we want to find the derivative of this function where f of x is given as 7x squared plus 4. And I remind you that we are dealing with the definition. And I mentioned it, it's coming up in upcoming sections. Some of you may already know the answer is 14x just by looking at it. But for this exam, we must use the definition. So the limit of f of x plus h minus f of x over h as h approaches 0, which means the limit as h approaches 0 of 7 times x plus h quantity squared plus 4 minus the same thing, this in the brackets, over h as h approaches 0. So you have to follow the definition. Of course, x plus h quantity squared is x squared plus 2xh plus h squared. You distribute the 7. So you get 7x squared plus 14xh plus 7h squared plus 4 minus 7x squared minus 4. In other words, you just do the elementary algebra and simplify the numerator. That's all. 7x squared and minus 7x squared cancel each other. 4 and negative 4 cancel each other. So we are left with 14xh plus 7h squared. In the numerator, we factor out the h, which gives us 14x plus 7h. We cancel out the h from the top and the bottom. And when you apply h equals 0, because you're taking a limit and h approaches 0, you get 14x, and you're done. And as I mentioned before, in later sections, we know the derivative of x squared is 2x times 7 is 14x. So you can get to this in a split second. That's not what we are doing here. The distance in feet of an object from a starting point is given by s of t equals 2t squared minus 5t plus 4d, where t is time in seconds. What is the velocity of the object from 2 to 4 seconds? This is the average velocity, which is total distance over total time. And therefore, S of T2 minus S of T1 over T2 minus T1 becomes S of 4 minus S of 2 over 4 minus 2. Which means you plug in 4, 2 times 4 squared minus 5 times 4 plus 40, you evaluate it, minus you plug in 2 and evaluate it, 2 times 2 squared minus 5 times 2 plus 40. The bottom is clearly 4 minus 2 or 2. 1632 minus 2012 plus 40 becomes 52. 4, 8 minus 10, negative 2 plus 40, 38. So 52 minus 38, we get 7 feet per second. Units are important when we do applications. Units of the numerator, change in distance in feet, over the units of the denominator, change in time in seconds, 7 feet per second. This was elementary algebra. What is the instantaneous velocity of the object at 4 seconds? This is calculus. Now, before we move on, it's important to understand that anytime they give you 2 points in time, that means average velocity. Anytime they give you 1 point in time, that means instantaneous, meaning whether they put the average here or not, whether they put the instantaneous or not, it means the same thing. So in this case, we are interested in instantaneous velocity. So the limit of S of A plus H minus S of A over A, H, as H approaches 0, where A is a 4. A is 4. So S of 4 plus 0. Now this is elementary algebra. You just simplify this expression and then apply the limit. In some instances, I see that people just work on this expression, which is the difference quotient. As you recall, they simplify it, and then at the last moment, they write the lim sign and they apply that. You can do that in any event. S of 4 plus H, 2 times 4 plus H quantity squared, minus 5 times T minus 5 times 4 plus H plus 40 minus S of 4. I can evaluate it, or just remember S of 4 was here or here, 52. You already have that, use that. Now, I'm assuming everybody remembers A plus B squared was A squared plus 2AB. Yeah, so let's just write it. A plus B squared is A squared plus 2AB plus B squared. Therefore, this is 4 squared or 16, 2 times 4 times H plus 8H plus H squared. Now you distribute the 2, becomes 32 plus 16H plus 2H squared. You distribute the negative 5 minus 20 minus 5H plus 40 minus 52. And now you are going to simplify as follows. You notice if we put all the numbers, 32 minus 20 plus 40 minus 52, all of them together, we get 0. They cancel each other. So in the numerator, we have 16H and minus 5H, that would be 11H plus 2H squared. We take the H out. We get the limit of 2H plus 11 as H approaches 0. And if you apply now you apply that, you get 11 feet per second. What I want to mention is, I've seen in some instances, sometimes students write 2H plus 11 and then they go to 11, which is wrong. This is not 11, this is 2H plus 11. What is correct? Because of the limit, this is correct. So you want to make sure you carry the limit for this guy, you keep the limit here, And now you drop it 11 feet per second, units of the numerator over the units of the denominator, change in distance over change in time. So any application, you must answer it back with the proper units. Find an equation of a tangent line to the parabola y equals x squared at the point p comma p with coordinates 1 comma 1. Again, they don't have to give you both. Even if they give you x coordinate is good enough. And so in this case, if we want to go with a, okay, we are looking at a being 1 because we want to find f prime of a. The pair is given, we want to find this slope. A is 1 and the function of y or f of x equals x squared. So we are going to apply one of these. For practice, I'm going to do both, everybody. So I'm going to go with this method. I'm going to show you the other one in a moment. And so limit of f of x minus f of a over x minus a as x approaches a. And we replace f of x with x squared. F of a, you can plug it in or notice the y coordinate is given. Okay. So f of x minus f of 1 over x minus a, because we want m, which is f prime of 1. So this is x squared and this is 1. And everybody remembers factoring. A squared minus b squared is a minus b times a plus b, and that's what we are using here. And now if you plug in the 1, you get 2. And that's the main part, which is calculus. The rest is basic elementary algebra. Y minus y1. That means y minus 1 equals m 2x minus x of 1, x minus 1. And you distribute the 2 and then you move the negative 1 and you get y equals 2x minus 1. Now it's important to know at this point, if you plug in this pair and it works, it shows this process was correct, doesn't say anything about the slope, okay? And we are done with this. However, for practice, I want to do this part also, so we get enough practice. In this case, f of a plus h minus f of a over h, where a is replaced with the x coordinate of the given pair, or namely 1. So we are going to evaluate f of 1 plus h, which becomes 1 plus h squared. F of 1 is given, you don't have to evaluate it. And 1 plus h squared, when we square this expression, we get 1 squared, which is 1, plus 2 times the first times the last, plus 2h, plus h squared. And then 1 and negative 1 cancel each other. The numerator, I can factor out the h, and these two cancel each other. And now if I look at the limit of 2 plus h as h approaches 0 and apply the 0, I get 2. And this is the same as what we found here. Again, we didn't have to do the second method. I just wanted to make sure we are exposed to both methods. That's the only reason we are doing that. We want to find the equation of a tangent line. So the graph of this function, f of x equals square root of x, and the point is given the pair 16, 4. Please understand, if they give you x, you just plug it in, you get 4. For example, if they said, okay, at x equals 25, you plug in, you get 5, 25, 5. So you should be able to come up with the y code. And so what we want to do, we have the pair, we want to find the slope. And over here, a is 16 and f of x square root of x. So m is the limit of f of a plus h minus f of a over h as h approaches 0. Let's look at this one and replace the a 16. Now, what is f of 16 plus h? We're going to replace this and we get the limit of square root of x plus h minus f of 16. I can put the 4 there. Or on purpose, I'm going to keep it as square root of 16 because I want to make sure you understand that if you plug in, you do get 0 over 0 indeterminate form. And the technique is to multiply by the conjugate of the numerator. Again, either square root of 16 or 4 is your choice, makes no difference. Understand that means the same thing. The conjugate of the expression in the numerator takes a plus sign here. So we multiply and divide by it. And this expression is equal to 1. A minus b, a plus b. The answer is a squared minus b squared. So each one gets squared up and comes out. The other one, of course, we already know. Okay, it's 4. But anyways, that's what happens. And 16 and negative 16 cancel each other. We have this one. The h cancels out the h in the denominator. And now if you're done, there's nothing else you can do to simplify it further. Now if you plug in, you get 16 here, square root of that is 4, this is 4, this is 4, 1 over 8 is the answer. Practically, we are done. That's the most important thing, y minus y1. That means y minus 4 equals m, that means 1 over 8. X minus x of 1 means x minus 16. And you are going to distribute and simplify the right side is 1 over 8x minus 2. This moves, becomes plus 2, plus 4, resulting in plus 2. And if you plug in the pair, when it works, it means this process is done, right? It doesn't say anything about this, whether we came up with this slope properly or not. Here's the second method for practice, class, for practice. You don't have to do this. So the limit of f of x minus f of a over x minus as x approaches a, where a is obviously 16. So m or f prime of 16 is f of x minus f of 16 over x minus 16. Where f of x is square root of x and f of 16 is 4. So f of x is square root of x and f of 16 is 4. Again, if you plug in, you get 0 over 0. Because the numerator has a square root, you have to multiply by the conjugate and divide by it. The conjugate for this one, you just change this sign to a plus 4, multiply and divide by it. Again, I can't emphasize this enough, as we did it here. The denominator, nothing happens. You keep it as a product of x minus 16 and square root of x plus 4 because x is approaching 16, makes this one 0, and the denominator being 0 is a problem. That's what you want to get rid of. Now, what is the numerator? And I hope you recognize this product as square root of x, quantity squared, minus 4 squared, which makes it x minus 16. These two cancel each other. And now if you plug in 16, you get the same slope, 1 over 8 that you got here. Same answer. Again, two different ways. Do we have to do it both ways? Absolutely not. That's it.